the first couple of sections in Chapter 5 are really trying to get you to work with the identities, to get comfortable with making substitutions. And so some of the problems you see, like this one right here, are problems that we've worked before using the definitions of the trig functions. And we can also use the identities to solve these problems. So the definitions using x, y, and r and drawing a triangle, that's really quick, easy, accurate to do. So I recommend that you use that on the test and anytime that time is an issue. But I also, on the homework, recommend that you use the identities method that we're going to go over here so that you get comfortable with working with those identities, because in the long run, that will save you time later in this chapter. So they're asking us to find sine theta. They could just as easily ask us to find the 5 remaining trig function values, and some of your problems will say that. They're asking us to find that based on a given value for one of the trig functions and then enough information to tell what quadrant our theta is in. So what we need here, if we're going to use identities, is an identity that as closely as possible relates what we're given, secant, with what we're looking for, which is sine. If you look at your list of identities, there's not one that directly relates sine and secant. However, there is one that relates secant and cosine. I know that if secant theta is equal to 3/2, then cosine theta is the reciprocal of that, 2/3. And then once I have cosine, there's a very direct and often used, probably the most used identity between sine and cosine, and it's that Mama Pythagorean theorem. Sine squared plus cosine squared is equal to 1. So I'm going to use this identity to get a value for sine theta. Now I do need to know what quadrant theta is in, and that information can be found by looking at the fact that secant is positive or even that cosine is positive, and then this little piece of information which says that tangent is less than 0, tangent is negative. If I draw my all students take calculus quadrant here, then I remember that cosine and therefore secant is positive in quadrant 1 and positive in quadrant 4. If I look at the other piece of information that says tangent is negative, well, tangent's going to be positive in 1, so that's out. Tangent is negative in quadrant 4, and so this is either where my triangle is going to be if I'm using that method, or it's where my theta is. And if I choose between positive and negative for sine in quadrant 4, I'm going to have to make the choice of negative, because sine has to be negative in quadrant 4. So let's go back to our identity and let's solve this for sine theta. Sine squared theta is equal to 1 minus cosine squared theta, just subtracting cosine squared from both sides. And this is a form of the identity that you're going to have to get comfortable with, and you're going to have to be able to recognize that as sine squared theta. And if you practice, then you will be able to recognize it. So now let's take the square root of both sides, which means I need a plus or minus on this side, plus or minus the square root of 1 minus cosine squared theta. I know that I'm in quadrant 4 and that the sign is going to be negative there. It's going to have a negative value. And then I'm ready to substitute for cosine theta. I'm going to substitute 2/3. So I have 1 minus 2/3, and then since the cosine is squared here, the 2/3 has to be squared. Now the rest of this is some arithmetic and some algebra. So I know that if I square the 2/3, I'm going to square the 2 and get 4. I'm going to square the 3 and get 9. So I need to think of this 1 as 9/9 so that I have a common denominator right here. Once I get a common denominator, I can just subtract the numerators and I get the square root of 5/9. When you have a quotient, you can take the square root of the numerator and the denominator separately. So this is going to equal negative square root of 5, which will not simplify any further, and then square root of 9 on the bottom is going to reduce to 3. And if you follow your equal signs back, you see that that's the value for sine theta. In my opinion, problems like these that are multiple choice are the most difficult to work with, because you never really know what substitutions they're making to the expression to get to one of these. And there are lots of substitutions that you can make. So really you just have to jump into it, make some substitutions, see if it works, and you just have to learn what usually works and what usually doesn't work. You know, probably changing tangent squared to 1 over cotangent squared is not going to be that useful. So you want to pick something that's a little easier to work with. Look at your list of identities. You see the squares on there, so I'm thinking probably Pythagorean identities. And there is a relationship between tangent squared and secant squared. This is not a rearrangement of your identity. 1 plus tangent squared equals secant squared. However, we can use that identity to make a substitution either for tangent squared or for secant squared. I'm going to go ahead and make the substitution for secant squared. So I have my tangent squared x minus, and then I'm going to substitute two terms, 1 plus tangent squared, for this secant squared right here. So I'm going to have to group that 1 plus tangent squared, which is what I'm replacing secant squared with, and I have to group it because this negative that's out front has to be distributed through. Now if I do that algebra and distribute that negative, then I'm going to get minus 1 and then minus tangent squared. Now do you see what happens? The tangent squared and the negative tangent squared cancel each other out. They subtract out, and I'm left with negative 1. Now the problem is that none of these answer choices look like negative 1. So what I have to do is look at the answer choices. Since this is the path of substitution that I worked on, I have to then look at my answer choices and see which one of those could equal negative 1. And as you go through the list, this one's out because sine squared plus cosine squared would equal positive 1, and the signs are not exactly opposite of what you need. So this one is not going to work. And you just have to go through and analyze these. This one's not going to work. The cosecant squared, that's not going to work. That's not equal to negative 1. Sine squared over cosine squared is not always equal to negative 1. So I'm left with B and C, and each of those looks like a rearrangement of 1 plus cotangent squared equals cosecant squared. So if we get our cotangents and our cosecants on the same side, like both of these examples have, then that should help us determine which one of these is our answer. So let's subtract the 1 because we need it to be negative. So cotangent squared x is equal to cosecant squared x minus 1. That gives us the negative 1 that we're looking for. Now we want both the cotangent squared and cosecant squared on one side, so let's subtract the cosecant squared. That gives me cotangent squared minus cosecant squared equals negative 1. So this is my answer choice right here. Now maybe there was a shorter way, but identifying the shortest way sometimes takes longer than just working it a couple of different ways. So lots of options there, but that's one way that you can get to that multiple choice answer.